Okay friends, so in the next lecture of three-dimensional geometry, now we are going to consider a plane. So let us now talk about plane. The first thing that we must do in plane is to find a normal form, and this will form the basis of the equation of plane. Let us consider a plane. This is origin O, and from the origin I am drawing a perpendicular on this plane. Let us take this point as R, X, Y, Z. Let this be any point on the plane. Let us take this point as M. Let us take length OM as P. And a unit vector along OM as E bar. So what do we have OM bar? Unit vector multiplied by magnitude. So OM bar can be written as E times P bar. OM bar can be written as P times E bar, where P is the magnitude and E bar is the unit vector. P is a scalar, it can be any number, and E bar is a unit vector. So the length of perpendicular from origin onto the plane is P. Now we are going to develop the normal form with the understanding that OM bar is P times E bar. Now see, OM and MR are perpendicular, so their dot product is going to be 0. So as MR bar is perpendicular to OM bar, MR bar dot OM bar. What is MR bar? R bar minus M bar dot OM bar is same as M bar only. So that gives you R bar dot M bar minus M bar dot M bar is equal to 0. Now please note, since O is the origin, OM bar is nothing but M bar. So what is M bar? M bar is nothing but P times E bar. So let us put it over here. So R bar dot P times E bar minus P times E bar dot, as P is a scalar we can take it out, so we can take P R dot E minus P into P is P square into E dot E is equal to 0. Now please note, E dot E is 1. Why? Because E dot E is mod E into cos theta. The theta is the angle between two same vectors is 0, and E is a unit vector having a magnitude 1. So E dot E will be 1. Let me elaborate it over here. E dot E will be mod of E into mod of E into what is the angle between them? 0. So as E is 1 and cos 0 is 1, E dot E is 1. Right? So what do I get? I get P times R dot E equal to P square. PP will cancel and you will get R bar dot E bar equal to P. This is the normal form of the plane. Please understand significance. E bar is a unit vector along the normal. As OM is a perpendicular, it is also called as normal. So E bar is a unit vector along the normal to the plane, and R bar is any point x, y, z. So now let us take the unit vector in terms of direction cosines as L, M and N, and let us develop a standard equation of the plane. So what is R bar? Xi bar plus Yj bar plus Zk bar dot, let us take E as Li plus Mj plus Nk equal to P. If you take the dot product, you will get Lx plus My plus Nz equal to P. What are L, M and N? L, M and N are the direction cosines of normal. What is P? P is the perpendicular distance from origin. So this is the significance of normal form of a plane. Lx plus My plus Nz equal to P, where L, M and N are direction cosines of normal. Now you know what are direction ratios. Direction ratios are any numbers that are proportional to direction cosines. So suppose to this particular equation Lx plus My plus Nz equal to P, I multiply by a certain number. Let us say I multiply by 2, or I multiply by 5, or I multiply by 5 by 2. Then what I will get? L, M and N will be converted into some other numbers, and they will be the direction ratios. Let these numbers be A, B and C. So multiplying L, M and N by a particular number, suppose I get A, B and C, then what I will have is AX plus BY plus CZ, and if I get multiply P by some other number, let us say I get some number D. So this is the general equation of plane where A, B and C are not direction cosines, the direction ratios of normal. And D is any real number. In fact, many times we write the equation as Ax plus By plus Cz plus D equal to 0. This is a more common way of writing. Now since D is a constant, we write on right or left makes no difference. The format remains same. So remember this equation. Ax plus By plus Cz plus D equal to 0, where A, B and C are direction ratios of normal. Lx plus My plus Nz equal to P, L, M and N are direction cosines of normal, and P gives you perpendicular distance of the plane from the origin. No such significance is here for D. D is any real number. So this is the general equation of plane Ax plus By plus Cz plus D equal to 0, where A, B and C are direction ratios of normal to the plane. So just remember it. So this is the basis. Now let us do a few formula here. One important formula is perpendicular distance of a point from a plane. Let us just quickly write it down for you. You can note it. Suppose this is the point P, x1, y1, z1. This is the plane. Then the formula for perpendicular distance is given by ax1 plus by1 plus d under root of a square plus b square plus c. So this is the formula for perpendicular distance of a point from a plane. Just remember it, it's a very important formula. ax1 plus by1 plus cz1 plus d upon under root of a square plus b square plus c square. Now suppose they ask you what is the angle between planes. So please remember, angle between planes is same as angle between their normals. So if n1 bar is normal of one plane and n2 bar is normal of another plane, you can simply use the formula n1 bar dot n2 bar equal to mod n1 into mod n2 into cos theta, and that gives you the value of theta. So angle between the planes is same as angle between the normals. See the next formula now. We will find angle between line and a plane. Suppose this is a plane and this is a line. You have to find this angle. So this line is having direction ratios b bar. B bar is a vector along the line, and n bar is a vector along the normal. So as this angle, this total angle is 90 degree, this angle will be 90 minus theta. So you can see that n bar dot b bar will be mod n bar into mod b bar into cos, but what is the angle between n bar and b bar? Not theta, it is 90 minus theta. So what we will get is n bar dot b bar as mod n into mod b into sine theta. This gives you the angle theta, which is the angle between the plane and the line. So this is another formula that might be asked in the exam. They are very simple sums. There is no need to elaborate or solve any examples on this basis. They are just pretty simple examples. Just put it in the formula, I'll get the answer. Now let us do a few illustrative examples, simple examples, and then we will go for the complicated ones. Find the equation of plane which is parallel to and which passes through now we know if two planes are parallel, then their normals also will be parallel. It means the direction ratios of normal will be same. So the required plane which is parallel to this plane, this 2, 3 and 4 will not change. Only this constant will change. So the required plane will be 2x plus 3y minus 4z plus d equal to 0. We just have to find the value of this d. To find the value of d, I am going to put x equal to 1, y equal to minus 3 and z equal to 4. So 2 into 1 and what does that give me? 2 minus 9 and that gives me d as 23. So back substitute here and the answer is, the required plane is 2x plus 3y minus 4z plus 23 is equal to 0. Another commonly asked question is to find the equation of plane passing through 3 points. It's a very commonly asked question. Equation of plane passing through 3 points. So let us see one example of equation of plane passing through 3 points. So for indication of plane passing through 1, 2, 3, 2 minus 1 minus 1 and 4, 5, 7. Let us take these points as A, B and C, and let us take R, X, Y, Z as any point on the plane. So what is the situation we have here is that we have 3 points, say A, B, C, and we have R. What we'll do is we'll pick up any one point, say A, and we'll have vectors AB bar, then I have vector AC bar, and then I have the third vector AR bar. As these three lie in the same plane, their box product will be 0. This is what we are going to use to find the equation of plane. AB bar, AC bar, AR bar का box product will be 0 or the scalar triple product will be 0. So let's do that. Please help me with AB, AC and AR. AB bar will be B bar minus A bar, so 2 minus 1, that is 1, minus 1 minus 2, minus 3, and minus 1 minus 3, minus 4. What is AC bar? You can see 4 minus 1, 5 minus 2, and 7 minus 3. And what is AR bar? X minus 1, y minus 2. Now all that remains is to solve the determinant and you'll get the answer. I'll leave that to you. Let me just put it in the formula. 1 time 3 into z minus 3 minus 4 times y minus 2 plus 3 times z minus 3 minus 4 times x minus 1 minus 4 times just solve this equation and you'll get an equation in x, y, z, and that will be the equation of the required plane. So it is as simple as that. You can easily solve this example. In the next part we will solve some more complicated sums on plane and combination of lines and planes.